Alright, I'm going to do general recon on the turbo system for the EcoBoost. You can see in the picture here you got your air filter. So your incoming fresh air is going to travel along this tube, come down, enter the compressor part of the turbo, or it'll centrifugally compress the air, make it denser, but it also makes it hotter when it compresses it. So it'll exit the compressor and then travel down towards the intercooler. It'll come into the intercooler. It's basically an air-to-air radiator, which will cool the heated air so that it becomes denser. And then when it exits the intercooler, it'll come up through the throttle plate and into the intake manifold. And the engine isn't in this picture. The intake manifold on this side, and then your exhaust is coming out and entering here, and entering your the exhaust turbine part of your turbo and spinning it. So the basics of the turbo is that you've got the hot exhaust gases coming out of the engine, and the faster the engine goes, the more hot exhaust you have coming out of the manifold. It's basically just going to get wasted and shot out the muffler. But with the turbo, it captures some of that escaping hot gases to spin the exhaust turbine wheel, which is directly connected to the compressor turbine wheel, and basically giving you free compression just from exhaust gases that would just be dumped out. And the other two components of the turbo system is your diverter valve, which is usually in between the compressor turbine and the intercooler, somewhere in this tube. And then your wastegate valve, which basically will divert exhaust gases coming out of the exhaust manifold away from the exhaust turbine wheel. In certain situations, you've got a lot of exhaust gases coming out, and the turbo is really spinning fast, and then you take your foot off the gas. Well, you don't need the turbo spinning at a high speed. You're going to get a backup of gases in the compressor, so you need to slow the turbo down by dumping exhaust gases, or bypassing them past the exhaust turbine, and just dumping them into the exhaust. And here's a little better picture of the turbo itself. You can see this would be the exhaust gases coming out and spinning the exhaust turbine wheel. And you've got your with the rod directly connected to your compressor turbine wheel. And here you can see like the wastegate valve. You've got a rod that goes into a vacuum type valve, which is modulated by the computer, the PCM, and it just turns I think it's a poppet type valve, opens and closes it. And then in this picture you can see the bypass valve. Here I think this is what they call a remote bypass valve. Some of them are built right into the turbo itself, but in my Mustang it's remotely mounted between the intercooler and the turbo, and it is pulse width modulated by the PCM as well, and so you get the dance between the wastegate valve and the bypass valve, controlling the turbo, either dumping gases out of the intake of the compressor turbine or the exhaust, depending on the situation, RPMs, etc. And you can see in this diagram here is this tube here is running from your air filter, and it's got the incoming air, the ambient air, is running down the tube here into the turbo here, getting spun around, compressed, coming back out this way and coming up, and then there's a split in here between there's tubes that are hard to see in this diagram, but you've got this main tube going back down into the intercooler for this compressed air to be cooled, or if the bypass valve is open, there's some bypass tubes which will just dump the air basically back into the intake tube here. I took some video of my car, and here you can see, it's hard to see, but the turbo is behind this heat shield here. The exhaust part, the exhaust turbine wheel of the turbo is behind this this heat shield. This is like the pillar shock tower, and the firewall will be on this side, and then the radiator in front of the car is over here. So on the side of the car, facing in, and here you can see the wastegate actuator valve here with the rod coming out, and it goes underneath the heat shield there. And there's if the heat shield wasn't there, you can see just like the other picture I showed, where you have the wastegate valve to open and close, and then along here you've got the you can see this is the exit. This is the compressor part of the turbine here, and it compresses the air, and it exits here. This is the tube that's going to be running down towards the intercooler. A little clearer picture of the actuating rod running below the heat shield to the wastegate. And then over here you can see the bypass valve, and you can see there's some bypass plumbing here, and the bypass valve itself, which is pulse width modulated by the PCM, and to open and close the bypass valve, and then dump the air back into the intake section if it's I don't know if it's open or closed, which mode it dumps it in there. So in the manual, the turbocharger bypass valve prevents backflow through the turbocharger when the throttle is rapidly closed to avoid undesirable noise. The high pressure downstream of the turbocharger is vented back to the intake air upstream when the turbocharger bypass valve is open, reducing pressure in the system. So when you're going down the high, or you accelerate real, slide the pedal to the floor, and then the turbocharger spins up like 100,000 RPM, and then you take your foot off the gas quickly, you'll have all that built up compressed air and exiting from the turbocharger compressor, and the engine doesn't need it at that point because your throttle plate is closed. So you're getting a lot of back pressure, and it's got to go somewhere, so that's the bypass valve opens up and vents it back into your air intake. And there's three types of turbocharger bypass valves currently in use. The first type of turbocharger bypass valve is solenoid controlled and located between the turbocharger intake and the turbocharger boost pressure output to the charge air cooler, which is basically the same as the intercooler. And the second type of turbocharger bypass valve is solenoid controlled as well, and it's integrated into the turbocharger housing. The operation of the turbocharger bypass valves are solenoid controlled is similar. And then there's a third type of bypass valve, which is electro-pneumatically controlled system integrated into the turbocharger housing that consists of a pneumatically controlled turbocharger bypass, a vacuum source from a vacuum pump, and a controlled solenoid for the vacuum and pressure and the tubing. So what I'd like to do is if try this bypass valve operation check, if I can get access through ForeScan to these PIDs where you the ignition's on, the engine's running, access the PCM and control the turbo bypass mode PID and the turbo bypass 2 mode PID, and command both of those to the off, and then access the PCM and control the turbo wastegate PID, and command the turbo wastegate PID duty cycle to 0% because it's not in this list. Mustang isn't in this list, so command it to 0%. Access the PCM and monitor the turbocharger bypass pressure PID, and access the PCM RPM PID and command it to maximum RPM, or if that PID's not available, you can use your accelerator pedal and just hold it at 2000, and then record the turbocharger bypass PID reading and command the turbo bypass and bypass 2 PIDs on, and then record the reading and see if what kind of change you get in it. So that'd be an interesting one to do this test, as well as a similar test on the wastegate operation. We'll have to see if I can get access to those PIDs through ForeScan. That'd be for another video.